Today we're looking at section 6-7, box and whisker plots. We have a couple goals. Drawing box and whisker plots to organize real-life data and then reading and interpreting them in regards to real-life data. We'll look at a car problem later. First definition, we have a few definitions. First one, box and whisker plot. Box and whisker plot is a data display that divides it into four parts, or divides it into quarters. Most people in here are familiar with box and whisker plots. It looks like a box with the two whiskers that stick out. Uh, Again, most of y'all have seen that before. You might not remember what everything is, but everything that it shows, including what'll be in the middle right there, it shows everything. This one shows you a minimum value, and this one shows you a maximum value. Those are the two easiest ones to understand, the minimum and the maximum. And then what's known as the Q2, or the second quartile, which we'll look at in a second, that's your median. That's your median value. Remember, median from the last lesson is the numbers when they're in order. It's the one that's in the middle. The Q1 is the one that falls at the beginning of the box, and the Q3 falls at the end of the box. And those are just the medians of the first half and the second half, respectively. We'll look at those. Second quartile, notice it's out of order: second, then first, then third, because the second is the one that you find first. It's the median. It's the number that separates it into two halves. So if you have a set of data, the second quartile, the Q2, or the median, cuts it in half. First quartile is the median of the lower half of the data. So if you have a set of data that looks like this, for example, just where we don't have to put any numbers into it, your median, when it's in order, your median or your Q2 would cut it in half directly. That's your second quartile, Q2. Your first quartile, same set of data, our median cut it in half. Your first quartile will cut that in half. And then your third quartile, just like that last one, you set of data, your median cut it in half. Your first quartile cut that part in half. Your third quartile will cut the second part, or the top half of the numbers, in half. Example number 1 says find the first, second, and third quartiles of the data. Easiest thing to do with this, just write them in order. Find the halfway point, and then take each of those halves and find the half of those. So the first thing we're going to do is we're going to take each of these values and we're going to write them in order. When we do so, the number values should look like that. Notice -5 is listed twice, 2 is listed twice, so is 4 and 10. While you're writing those numbers, make sure you cross them out to where you don't make a mistake and either leave one off or count one more than it should be counted. Notice there are 16 values there. There are 16 values, so your middle number will not be an easy one that you can just grab. You have to count 1, 2, 3, 4, 5, 6, 7, 8. It's going to be the number between 2 and 4. Now, it's easy for most of us to understand the number between 2 and 4 is 3, but if it wasn't quite so easy, you just follow this process right here. Add 2 plus 4, and you'll get 6. When you divide it by 2, you get 3. Once that first part is split in half, or once it's split top half and bottom half, then go ahead and take the top half, or the smaller values as we're looking at them on the left, and split those in half. So there were 8 values, so now you're going to count 1, 2, 3, 4 of them. So the number that's directly between those two is going to give you Q1, and we'll do the same thing to find our Q3. Notice from -2 to 0 is not as easy as what's between 2 and 4. So for most of us, we need to add -2 plus 0, you get -2. And when you divide it by 2, or you average it out, you get -1 as your Q1. We'll do the same thing with our Q3. Again, there's 8 values, so 1, 2, 3, 4. The number that's directly between 8 and 10 will give you your Q3. And that one's a whole lot easier than the last one, because the number directly between 8 and 10 is 9. So your third quartile is 9. Again, don't try to make it any harder than it is. Take the data, put it in order, cut it in half, and then cut each half in half. That's all today's lesson is. Drawing a box and whisker plot, here are the steps that you need to follow. Plot the least number, the first quartile, the second quartile, the third quartile, and the greatest number on a number line. So you need to, once you have your values of all of them, you need to draw a number line from least to greatest, or the smallest one to the greatest one. You don't need to include numbers that are smaller than the smallest one you're looking at, nor do you need to include anything that's larger than the largest one you're looking at. And then step number 3 is to just make a box from the first to the third and draw a vertical line at the second. And we'll look at exactly how to do that on example number 2 in just a second. Okay, notice mine is upside down compared to you guys. We're going to actually work through it real quick. Example number 2 says draw a box and whisker plot of the data in example number 1. So it says plot the least number, the first quartile, the second quartile, the third quartile, and the greatest number on the number line. So go ahead and find each of those values. Your smallest number was -5. So this will be our smallest number, or our minimum. If we look at it that way, that's our minimum. Actually, let me get that out the way for now. That's time we'll put it on top. That's our minimum. First quartile's value is -1. That's our Q1, our first quartile. Second quartile is going to be 3. So at 3, that's our Q2, or our median. Third quartile is at 9. That's our Q3. And then our greatest number, or our max value, is at 15. That's our max. Now notice, as you're looking at these, what a lot of people do when they draw these, the only mistakes I ever see anybody make is they'll try to make them uniform. Notice the distance between Q1 and Q2, how much shorter it is than the distance between Q2 and Q3. Notice how much shorter this value is compared to this one. They're not going to be even more often than not, and that's okay. They're not going to be even. So the first thing you want to do is you want to plot those things. The next thing, you want to draw a line from -15, from -5 to 15 below the number line, and plot each of those on that line. So it says below it, we'll draw ourselves a line from -5 to 15. And we'll just draw ourselves a line between those. Plot -5, we have -1 again. We have 3, and we have 9. Then the last step we want to do is we want to make a box from -1 to +9, or you want to make a box like so from your Q1 to your Q3. Want to make a box, and then draw a vertical line at your Q2. And that will be your box and whisker plot. More often than not, you'll see it look like this. That's a box and whisker plot, as simple as that. Again, just separate the data in half based on the numbers that are given, and then take each half and separate those two in half. Checkpoint number 1 says complete the following exercise, making a box and whisker plot of this data. Now we have a whole lot of values. Notice what your smallest value is. It looks like 1, and your largest value looks like 7. There's no need really to go any smaller than 1 or any larger than 7. So none of this here is really necessary. You might want to go 1 past it, like to 8, but other than that, it's not really necessary to go any farther. What we're going to need to do is we're going to need to put all of this data in order. Now, there's a lot of 1s, so you want to count them out. 1, 2, there's 3 of them. So 1, 2, 3. Then how many 2s do you have? There's 1, 2, 3 2s. Then how many 3s? 1. And this is the most tedious part, but if you make a mistake here, so you'll make it'll throw everything else off. 2, 3, 4, 5, 6, 7, 7 3s. And what I mean by tedious, it's not hard, but if again, if you make a mistake, it'll make it look like you don't know what you're doing, even though most of y'all will. Then how many 4s do you have? 1, 2, 3, 4, 5, 6, 7, 8. There are 9 fours. So if we were just doing the mode right here, the mode would be easier. It would be 4 because there are 9 of them. Then how many fives do we have? 1, 2, 3, 4. There's 5 fives. How many sixes? 1, 2 sixes. And then how many sevens? There's only 1. So we need to find out how many values we have right here. As we count these, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 30 values up there. That's how many I counted, 30. So what you need to do is you need to count to number 15, and it's going to be the number between 15 on the left and 15 on the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So it's going to be the value between 4 and 4, which is simple. It's the same number 4. And you can see the way the box and whisker plot is going here. This is your Q2 value or your median. You can call that either the second quartile, the Q2, or the median. Then what you want to do, since there's 15 values on each side, you want to count the left side or the smaller side. There's 15, so that's an odd number, so you want to get to the 8th one. 1, 2, 3, 4, 5, 6, 7, 8. That is your Q1 value, and you can see your Q1 value is 3. And then do the same thing with your other side. Count to 8. 1, 2, 3, 4, 5, 6, 7, 8. 5 is our Q3 value, our third quartile, and you can see 5. Notice the box goes from the Q1 to the Q3, just in this case from 3 to 5. And then your whiskers, what goes out from 3 to 1 and what goes out from 6 to 7, 5 to 7, those are your whiskers. That just shows your minimum value, in this case 1, and your maximum value 7. So your box and whisker plot should look like that. A lot of people will take that box and put it on top of the number line, which is just as good, if not better. Then it's talking about mid-size versus pickup trucks, mid-size cars versus pickup trucks. It says, what's the median city driving gas mileage of mid-size cars and then pickup trucks? It's really easy. Remember, it's your Q2 value, and box and whisker plots make it easy for you to see. So for mid-size cars, it's 20, and for pickup trucks, it's 16 miles per gallon. It says which one has better overall city driving gas mileage. Now, most people would understand in here without even looking at this charts that the cars would have better than the pickup trucks, but let's see just why the cars have better than pickup trucks. It says the mid-size cars get better than the pickup trucks. 3/4 of the mid-size cars have a gas mileage of 18 miles per gallon or higher, whereas only 1/4 of the pickup trucks have 17 miles per gallon or higher. This is a fourth of the data right here. This is a fourth of the data. This, even though it looks small, is a fourth of the data, and this is the final fourth. So look, there's 3 of them for the mid-size cars, 1, 2, 3 of them that are higher than 18. There's 3/4 of them. Whereas if you look at the same fourths when you're talking about the pickup trucks, only one of them, this one here, is higher even than 17. So that means 3/4 of them are less than 17. So the mid-sized cars have 3/4 that are higher than 18, and trucks only have 1/4 that's higher than 17. So a great difference there. And then it says, how else do they differ? Well, notice the minimum values are 10 for both of them. The maximum values are different. It says there's a little more variability in the mid-size than the pickup trucks, and this is just, you're going to have to go with the blanks as they look in here. The gas mileage for the mid-size cars span from 10 to 26, and then the trucks are only from 10 to 24 miles per gallon. So what that's called the extremes, or this is called the range of these, and that's an easy concept for most people to understand. The range of each of these from 10 to 26 and from 10 to 24, 16 versus 14 is the range. And again, extremes means from the smallest to the largest, And another term that's used interchangeably with range, extremes is range. 16 versus 14.